Hello, everybody. It's a pleasure to be able to talk to you in this way. I'm sorry I couldn't make it to the conference in the end. I really was looking forward to it. And thank you to Nancy and the organizers for the opportunity to join you in this way and talk to you a little bit about our work and also I think some of the connections to the issue discussing on urban agriculture. So, as you know, my name is Luís Bettencourt. I'm a professor at the Santa Fe Institute, and in my group we've been looking at cities now for a long time, over 10 years. And what we try to do is to look at cities as systems. So to look at cities not just as sort of massive engineering problems, but also at the social and economic dynamics, as well as other issues, including environmental issues. So in some sense, what I try to do is to try to make sense of the city as all these systems come together. And I think that it is from that perspective that one can also say something about land use in cities and also issues of whether, when and how agriculture and food production and other primary activities may be viable in cities or not. So from that perspective, let me start with the things I know about, which have to do really with how we may even start to understand cities. Cities are immensely complicated things. What you're looking now, I think, at a slide of Hong Kong. Hong Kong is one of the densest cities on the planet, at least as a developed city. And, you know, at once you get an impression of all kinds of things going on. Social life, but also use of space, a lot of information, and of course the engineering systems that allow the city to work in terms of transportation, lighting, and other infrastructure that's less visible. And so it may seem at first that it's very difficult to understand these systems in any quantitative way that's predictable. But it turns out that that's not true. And so the beginning of my talk will be a little bit about that. And the second part of it will be what does that mean in terms of agriculture in cities and for cities. So this is another slide. It's now New York. And it also reveals how as cities grow, a lot of their characteristics change. So obviously you're just looking here about maybe 150 years of development in New York, and you're looking at the built environment. But you can also see, if you squint a little bit at the lower panel, that there's more green spaces and there's a greater consciousness of the city as an integrated human and natural system, built space that's functional in some sense for offices and places to live, but also recreational spaces and green spaces that allow cities to not only make urban environments more pleasant, but also we start understanding have a functional role in terms of urban climates and also other functions, recreational functions and other things. So but cities are also like this. They can be extremely complicated and chaotic, and a lot of our work now is looking at developing cities and the kind of trajectories and the kind of problems, but also solutions that they offer for their own societies. So again, just to set up how I'm going to speak about this. The whole idea is to really look at all perspectives that have studied cities from the point of view of, say, geography or economics or engineering or physics, and really try to ask how they constrain each other in order to produce sort of a theoretical framework to understand what cities are, how they operate, and sort of the things that become possible and very difficult in urban environments. So it's really bringing together all these perspectives and in some sense trying to distill something new out of them in terms of a more connected, more integrated, but also in some sense more compact and more predictable framework to understand cities that's based on data. And that's really the big revolution, I'm sure you'll be discussing this, is that we have now the means to understand how cities work socially, in terms of infrastructure and services, in terms of organizations that build space, at a much more precise level on the whole, and much more precise level, much finer level in terms of what occupies what space and how things move around in cities and so forth. And so this is really exciting, and it's really opening up a lot of possibilities, not only to create sort of a general understanding of cities, but also to create the means by which we understand change and how, again, change in social and economic aspects of cities is connected to the more physical aspects of these environments. So in my group, sort of, when we started this, we started by looking at a lot of properties of cities. Too many, I'm just going to show you a couple of slides because otherwise it would be mind-numbing, but we've written down many papers showing that the properties of cities tend to be quite predictable in the following sense, that if you look at quantities like what you're looking here on the slide, is GDP of cities, each point is a city, and you're looking at 10 nations there in different colors. And as you look at population on the x-axis, you tend to see that the GDP of cities increases with population, but increases faster than population. That's why that line is above the dashed line. And what that means is basically something that's intuitive, and I think you all know about, which is the size of the economies of cities is larger the larger the city on a per capita basis. So that means that things are more expensive, but also more productive in larger cities than in smaller cities. And this is actually very important for land use and the composition of activities that become possible in smaller cities, in larger cities, and also in rural areas. So with urbanization, as we'll discuss in a second, what you tend to see is a shift of activities towards things that are away from primary production in larger cities, and primary production, at least historically, being concentrated then in areas that are less urban. And part of the question that I think you'll be discussing, and that many people are interested in now, is whether this extreme physical separation is necessary or always makes sense, or if other models of integration of sort of nature and agriculture and other forms of production in urban environments is possible, and how that could come about. So another example, this is now for European cities specifically. So there are several countries, again, the same idea there, represented in different colors. Some cities are highlighted there. But on the top, both panels A and B, what you see is basically, again, GDP, similar to what you saw in the previous plot. But on the right, you're looking at urbanized areas. So this is all the area that's built up in a city. And what's interesting about a city is that it doesn't build up space uniformly, but it builds up in all the places we have roads and houses and buildings and parking lots. But there's a lot of empty space as well when you actually look at a city. I'm sure many of you have done that, particularly through satellite imageries and measures, for example, vegetation. Different cities have actually different amounts of open space. And this fine integration of what we build and what we leave open, and what we cultivate of what we leave open, is very interesting. And it's also, at least sort of as a statistical pattern, beginning to be understood at a fine level. And it probably has a lot to do with things you'll be discussing. But the pattern you also see, and I'm going to show you empirical evidence on that, is that in larger cities more and more of space is built up. And that, again, reflects a choice of land use between places that are higher value for residence and work, but also a prevalence of infrastructure, things like roads and cables and other things that must exist to connect the city, and that start taking up more and more space, and therefore leave less space for other things. So the point about these things, I will not comment on the lower panels, but you can see basically that on yellow is a little bit of the theoretical framework we've been developing that I'll tell you about in a second, that tries to predict those properties on average. What it's telling you is that basically the amount of GDP per unit area, if you put A and B together, is really increasing very fast with city size. And this is actually one of the biggest pieces of logic, the thing that really allows you to start understanding why land uses and why agriculture has been, in some sense, expelled largely from cities in the trajectory of development that you observed over the last few decades. So we'll get to that in a second, but this just tells you this. So what you're seeing there is the same plot bringing A and B together, but it's basically telling that GDP versus urbanized area is increasing. I didn't put there the line that's just the slope 1, but the label indicates that basically with every doubling of urbanized area, you basically get a 33% increase in GDP. Or if you want to say it another way, that the price of urbanized area is increasing 33% as cities grow. So that's very quickly, and that implies that the land uses that can support that productivity must be aligned with the growth of cities. And so this is why different kinds of activities start shifting across the sort of city size continuum, with things that are lower added value at the bottom, and therefore in some sense in smaller cities and urban areas, and rural areas, and with things that are very large added value, high tech, finance, and other things, sort of at the other end. But there's always a mixture, and that mixture is interesting. So don't take that caricature of just the very high and very low added value as the extremes, and that's all that cities do. The mixture is interesting. And so I'll tell you now a little bit about how to explain these patterns very quickly. It's not the theme of what you're discussing, but it gives you a sense, I think, of the integration of these patterns and how they come together. So most of it's published in this paper a couple of years ago. And so the idea is to look again at the city as a system that's a system of people and their interactions in terms of social and economic exchanges, but integrated now into the infrastructure and built spaces that exist in cities. So this is a photo from Mumbai. Basically, you're seeing a train station. And I like this photo. It's a photo you see quite often because it also gives you a sense of the time scales, the fact that socioeconomic life is fast in some sense, and infrastructure and land use tends to change in response to it in part, but on a longer time scale. And as we know, in a place like Mumbai, too slowly for the kind of socioeconomic development that would be desirable and that people, and that in some sense is happening. But often in the United States, that also plays the opposite role, that land uses that were set in the past also determine what becomes possible socioeconomically, at least to some extent. So the idea is that you embed basically the idea of a network between people, as you see here, into space. And as you do this, you end up basically with a social structure whose probability by which people meet and interact is set to a large extent by how urbanized space is organized, and vice versa. Urbanized space needs to be organized in a certain way that allows people and their activities to function at a certain cost. This cost has to do with the productivity, the value of each meeting, but also with the ease by which people can move in this space. So basically the idea is that you put the social network and embed it in space. This is supposed to be a space of streets, and she's going around in her daily life and meeting a bunch of people. She derives, money as she goes to work, and she buys and sells things. She may catch a disease. She may have all kinds of things in her life. And so when you go to larger cities, what you find is that the city becomes denser and the probability of these encounters per unit travel increases. And this explains just very simply, there's a lot more I could say, but I'm not going to say, but just for you to get a sense of what happens sort of on average of how a city works. By densifying space and by increasing the possibility of contact, but also by diversifying those contacts, you end up with a system that allows not only more interactions between people, but the nature of those interactions to change. And so this predicts a lot of the properties of cities, including some of the things I alluded to, and I'll explore in a second. They have to do with how much land a city tends to take as a function of population. So this table summarizes some of that. And so land tends to increase more slowly than population, leading to increased density. That the networked volume, so basically the amount of infrastructure, grows even faster than land. So this is why infrastructure starts taking up a lot of surface and eventually needs to go underground and overground, which is sort of interesting, and it's a characteristic of large cities. But then other things like the productivity of economic interactions, which is now here just basically socioeconomic rates, but also very importantly the price of land. So the price of land, as I already indicated with that slide for Europe, increases faster than incomes because it basically compounds the effect of both spatial densification and increase in productivity per person. So when you put these two effects together, the price of land really skyrockets in cities. And this is sort of the essential insight that I think makes certain land uses, including agriculture, being very hard to include in cities. So let me get to that. And so what are all these interactions for? And this is also very important. They tend to thrive in sectors that require a lot of interactions. And what these interactions allow you to do is they allow people to specialize in things that they have competitive advantage on, people or companies, and to trade in these dense markets for other things. And so this is a mechanism not only to explore, again, mechanisms of comparative advantage at individual and corporate level, but it also gives you a way to embody more knowledge, because as you specialize, you also learn. And so systems that can embody this sort of urban dynamics are systems that are able to encapsulate more knowledge, and that's essentially the mechanism by which we produce innovation and economic growth. So this is why, in very quick and broad terms, cities produce the magic that they do in terms of the change that they produce in human societies. So that's more or less what I wanted to tell you, just sort of as context, and I hope this is useful. We'll see. But one thing that always needs to be said is that I just presented you sort of the average picture of what happens as cities get larger. But there are a lot of fluctuations, a lot of variations. They're both local to entire specific cities that perhaps are more industrial cities, or cities that developed in areas where they could develop at lower density. For example, newer cities tend to do that. And therefore, in some sense, they have higher carbon footprints in terms of the energy they need for transportation, but they also leave a lot more space open and allow space to be not quite as expensive. That cost is basically paid through transportation. So there are a bunch of trade-offs, both at the level of entire cities and then locally inside cities at the neighborhood level and other levels, that become important in determining specific policies. But nevertheless, I think it's interesting to have sort of a general view of what cities are doing and then understand that local change. We have a bunch of papers on this too, if you look at our website, as to how that may happen in detail. But now I want to just say a few words about things I think you know, but have to do with the temporal evolution in the past of what happened to agriculture in relation to cities, and maybe some possibilities for these systems to be reintegrated in the future. So what you see here is basically a plot that you might have seen before, which is basically the GDP of different societies. Each point here is a country now, not a city, and the percent urbanized population in each country. So basically, if everyone lives in cities, that would be 100%. That rarely happens. But what you see here is that basically GDP, and therefore wealth per capita, tends to go hand in hand with levels of urbanization. Korea there is emphasized as sort of a temporal trend. But as you can see, we only know how to produce rich societies if they're urbanized. And conversely, societies that are not very urbanized tend to be quite poor as a whole. So this is just an example, maybe hard to read, at least from where I am looking at my screen. It's hard to read, but what you see there on the left is basically the percent of value added of economic activities that's attributable to agriculture in different countries, so still countries. And what you see is that all those countries on the list, this is the top of countries by percent of GDP attributable to agriculture, they're all quite poor. So it's not only that what happens effectively is that as countries grow economically, they also, what is growing is not so much the value of agriculture in terms of GDP, but the value of other sectors. And almost GDP in agriculture in some sense is of course much transformed by technology, different practices and so forth. But what's happening is that this value is staying put, and its productivity in terms of energy is supporting a lot of the rest of society that lives in cities. But in some sense, it's very hard to support high GDP living or high GDP existence based on a large percentage of agriculture in terms of labor. And so another way of saying that, as you can see here, this is now for percent of the workforce in America, in the United States, whose primary occupation is agriculture, and you see it basically coming, all the way through the bottom until basically 1 or 2% of the population only are farmers. And not only that, but even though farmers' incomes actually have improved over the last few decades in terms of total income, what's been happening too is that even people who are farmers and own farms and manage farms, most of their income, as you see in the slide, does not come from farming. So again, it's very hard now at a more disaggregated level to make a living as primarily in agriculture. And so a couple other examples before we move on. What you see here is basically also demographics of farming. This is more recent data, but what you're looking at there is basically the age of farmers in the United States, and you see basically how despite sort of some movement towards people caring about farming in cities, you see essentially a demographic trend through people in farming becoming older, not younger. And also the fact that most farms that are being set up and are relatively recent rely, as we saw in the previous slide, essentially on income that comes from other sources and not from farming. So again, very difficult as the United States has urbanized, but even as it's grown and technology has been introduced in these processes in the last few years, to generate most of one's income as a farmer and have essentially a reasonable life. So these are conditions that make farming as sort of an urban economic activity very difficult to realize from a socioeconomic point of view. And I think that alone is really the greatest challenge. And what I want you to realize is that this is not only a purely economic model thing, but also has to do with the structure of the fact that if food, for example, were to become quite expensive in general, you would have to have a lot of people that could not be, that would likely not be able to afford to make a living in other urban activities. So there's really a trade-off between populations that lead a non-food production life, mostly in cities, and populations that lead a food producing life. And the way this has been solved is that agriculture has been increasingly, is one of the great success stories in terms of productivity increase, but in terms of labor productivity, not economic productivity. So a farmer today produces a lot of food, a lot more food perhaps. Well, just in rough numbers, you went from subsistence farming, where somebody produced food for a family of 3, 4, 5 people, to an industrialized farmer now with all the problems of that model, but creating food that if people ate corn or sort of the direct products of the most efficient crops, you would be producing food that could feed maybe 50,000 people. So this factor, about 10 to the 4, is really the factor that allows large cities to exist. So, so that's the problem. So what are the possibilities for urban agriculture, given sort of this context of both how cities work and of past development of how agriculture versus other activities has been structured in terms of separation between large cities and more rural areas. So I see 3 possibilities, and perhaps these are some of the ones you'll be discussing, but there may be others. The first is that the model we discussed is really that agricultural production and urban living are largely separated. But there are in fact lots of opportunities as we start to understand cities better, systems, to integrate these 2 activities better, so that agriculture also makes use of a lot of the resources that already exist in cities and in many ways are being wasted. So the most obvious one is, of course, things like water. I know some of you care about water and how it's cycled and recycled, but also other wastes, as well as some spaces that may be dual use, both as green spaces, recreational spaces, and as agricultural spaces possibly. So if this kind of model can be integrated and managed at a finer scale, that produces an opportunity for land use that is of food production, but that can exist in cities and can make cities better as well as produce food. So that obviously many people have been looking into this. And I think part of the challenge is to make sort of pretty architectural projects into things that have economic viability, but that's interesting to think about. So hand in hand with that is create very high value added markets that have to do with producing not general food, but producing very specialized food that again has high value and also typically has very high transportation costs. So it's always the tomato, right, as you see in this photo. But this is connected with urban farmers markets and with farm-to-table movements and other things, perhaps with certifications that will tell you whether your food comes from and comes from locally. It's increasingly common. But that basically creates the opportunity for food to be differentiated, to not just be the same thing, but to gain value from being production that's local, that's urban, and that is efficient and perhaps makes use, again, of urban resources. And finally, there are other opportunities for synergies, for example, in terms of how we understand microclimates in cities and how we try to make them better. So you've all seen, I'm sure, what I'm showing you there on the right, which is basically these green facades and vertical gardens and so forth. So cities that make use of green spaces not only in conventional ways, in open spaces, but also in built spaces, sort of in close synergy. And this may be true. I've talked to many people that do these projects. Most of these have been done in Asia. The one you see here is from Singapore, lots of them in Japan, parts of Europe. But what I hear as well as this is pleasant to many people and creates better environments, it's also very labor intensive. So there's really a question here of whether we learn to really build and manage buildings in a way that allow this sort of very close synergy of traditional built spaces and green spaces to exist. What I'm showing you on the left is basically motivation that may, whose value has not been internalized, basically an economic externality, but it has to do basically in this case with the urban heat island effect. A similar argument could be made about certain forms of pollution. But so the idea is that cities tend to be much warmer and in many cases, of course, generate environments that are too hot and that are unpleasant for people to live in. And so if you could start internalizing this sort of costs in terms of the creation of green spaces and perhaps the production of food, then you would have a cycle by which you could justify certain land uses that at face value may not have a sufficient market value, but that in an integrated way by which there's an economic model that internalizes many of these costs that so far have been paid indirectly, you could have a more viable system. But I think, again, I suppose, as I was looking for examples, that the real challenge is, again, how do you open space and how do you create value such that food production and green spaces in cities make sense sort of from a positive point of view and not just from sort of a mitigation point of view. So that's it. I just want to encourage you to think sort of as cities and urban environments and food production as well as energy management, all the things that happen in cities as sort of a system whose ultimate function is to encourage better lives. They're more interdependent, that create more knowledge and more value. But to think of that system and the many ways in which it could work in a slightly different way from the way it has worked, in a way that would open up space again and create value for food production. I think that that's the key, and I wish I could be there to join you to learn more from you about how you're thinking about this problem. So I'll more or less leave it there. I'll just leave you the last slide, which is a bit propaganda, but in conjunction with OpenStreetMaps, we're creating, we're sponsoring essentially a local week of mapping. The idea is to really understand urban environments at a very fine level and understand and reveal problems and possibly solutions about how these spaces can be managed. And by collecting data like this in many places, we hope to also create a better understanding, a scientific understanding, and sort of also understanding relevant for solutions that would allow us to understand urban spaces at a much finer grade. So there'll be sort of a big international forum of how to do this at the local level in neighborhoods and cities, and there'll be many people mapping, people in State Department and OpenStreetMaps and several federal agencies doing this, as well as many people in civil society throughout the world. So if you have any interest in mapping, get in touch with us about this. Thank you.
So I'm going to start describing a little bit of the problem of data integration, and in particular for our